Welcome to Unknown Source. I'm Mehedi. It's everywhere. Have you ever wondered how your online world works? Think about it. Every time you send money, like a post, or even just browse the internet, you're trusting someone else. You trust a bank with your money, a social app with your data, and a big server to keep the internet running. But what if there was another way? A way that didn't rely on one company or one computer, but a whole network working together. That's the big idea behind blockchain, changing how we think about trust, security, and the fabric of the internet. You've heard of Bitcoin. Digital money that proved value can move peer-to-peer without a bank. But blockchain is more than money. It's an engine powering supply chains, voting, identity, and more. Why care? It puts power back in our hands for a more open, transparent, and fair digital world. Let's dive in. Let's break it down. All right, let's get to the heart of it. What exactly is a blockchain? Imagine a digital notebook shared across thousands of computers all over the world, a distributed ledger. You can only add new pages. You can never go back and change old ones. Each page is a block of data. When a page fills, it's added to the end and cryptographically linked to the previous page, forming a chain. Two key ideas: transparency, anyone can inspect public ledgers, and immutability, past records can't be altered. Change one page and the whole chain breaks. Nodes notice and reject it. The result is a shared source of truth. Instead of trusting a person or company, we trust a system built on math and collaboration, a decentralized, distributed, unchangeable ledger. It's a simple concept with powerful implications. Science is cool. Blocks, chains, and nodes. The block is the fundamental unit, a transparent box that holds data. For Bitcoin, it's transactions, but it could be medical records, a vote, or shipment tracking. Each block has a unique code, a hash, a digital fingerprint of its contents. Change a detail, and the hash changes. Blocks include the previous block's hash, creating a link, a chain back to the first, the Genesis block. That chaining is what makes the history effectively unchangeable. Who holds the notebook? Nodes do. A node is a computer on the network, keeping a full copy of the blockchain. When a new block is created, it's broadcast. Nodes verify transactions and the hash. If it checks out, each node appends it to their chain. Security through massive collaboration. Imagine friends writing a story. Someone adds a paragraph, reads it aloud, everyone checks it, then all update their copy. If one person secretly changes a paragraph, the mismatch is obvious. Thousands of nodes reject it. That's the power of teamwork. Recap: each block holds data, its own hash, and the previous hash, chained for integrity, verified by nodes. Together, this design makes blockchains transparent, tamper-evident, and resilient. Public blockchains like Bitcoin and Ethereum are open. Anyone can join, run a node, view the ledger, and help add blocks. They're trustless. Rules are enforced by code for everyone. Private blockchains are controlled by a single organization, which decides who can join, see data, or add blocks. Think intranet versus the public internet. Consortium blockchains are governed by a pre-selected group. Great when multiple companies need to share and trust. Examples: international shipping and financial settlements. Public is permissionless. Private and consortium are permissioned. Access granted by the owners. Choose based on your needs. Decentralization versus control. Openness versus privacy. With many nodes, how do we agree on the next true block? Especially if two appear at once. Consensus mechanisms are the rules for decentralized agreement, like democracy for computers. Proof of work. Miners race to solve a hard puzzle. The winner adds the block and earns crypto. It's very secure. An attacker needs 51% of compute, but consumes massive electricity. Proof of stake. Validators lock coins as collateral. One is selected to add a block. Honest behavior earns rewards. Cheating loses stake. It uses far less energy. Ethereum switched to POS. PBFT suits smaller, permission networks. Nodes vote, supermajority adds the block. Consensus choice shapes speed, security, and decentralization. Blockchain began with crypto. Bitcoin and others showed global 24/7 peer-to-peer finance. Then came smart contracts, programs on the blockchain that auto-execute agreements when conditions are met. Supply chains, record every step from farm to shelf for traceability and safety. An outbreak? Trace contaminated goods to the exact origin in minutes, not days. Voting. Anonymous entries on an immutable, transparent ledger make tampering harder and audits easier. Voters could verify inclusion without revealing their choice. Healthcare. Patients control access to their records. Finance. Cross-border payments and trades settle in minutes. Creators. NFTs certify ownership of digital assets. Any industry built on intermediaries, trust, and records can be transformed. The experiments are happening now, changing our world. Security. No single point of failure. Cryptographic links make tampering prohibitively hard. Transparency. Public ledgers enable verification and accountability, from charities to budgets. Decentralization. Fewer middlemen, lower fraud and fees, faster automation with smart contracts, fundamental upgrades to how we operate. Scalability. Early chains process few transactions per second. Layer 2 solutions help, but work remains. Energy. Proof of work is power-hungry. Proof of stake cuts usage by over 99%. Making blockchain green is critical. Regulation. Taxes, laws for decentralized orgs, and governance of upgrades are evolving. Social and technical questions. Complexity. Mainstream adoption needs invisible UX. Like email hides, TCP/IP, future apps will hide blockchain. Bridging tech and people is the final frontier. Apps anyone can use without knowing the plumbing. Web 1, read. Web 2, read and write on big platforms. Web 3, read, write, and own. Users control data, identity, and digital assets. dApps look like normal apps but run on peer-to-peer networks that resist shutdown and censorship. IoT, billions of devices need trustworthy data. Blockchain can be the tamper-proof backbone. AI, log datasets and decisions on-chain to improve transparency and auditability. The future is rethinking systems to be more secure, transparent, and equitable across finance, shipping, healthcare, and government. Ultimately, blockchain empowers individuals to cooperate and build trust without powerful middlemen. Quick recap. Blockchain is a decentralized, distributed, immutable ledger that can transform how we trust and transact. Why learn it now? Because the decentralized future is being built today. Subscribe to Unknown Source for more, and stay curious.